In this problem, we have a ball dropping through some distance. The displacement is -8 meters. That means it's falling down. So there's a displacement in the y direction that is, again, negative. What is its final speed? If we drop this ball, it's going to start off with some velocity, which is equal to 0 meters per second. And then as it falls, it's going to fall. It's going to gain speed, and it's going to end up with some final speed, whatever that is, as an unknown. And the reason why it falls is that there's a gravity field present, which is tugging on this ball, and it will accelerate the ball at -9.8 meters per second squared. So if we're interested in solving for the displacement this ball experiences, we can apply the kinematic formula. V squared is equal to V naught squared plus 2 times A times D. You can recall that if the velocity is 0, the starting speed, that term goes away, and V will be equal to the square root of 2 times A times D, and the V will be equal to the square root of 2 times -9.8 meters per second squared times D, which is -8 meters. All of this falls under the radical, so we'll put everything in parentheses. And 2 times 8 is 16, roughly, times 10 is 160. So the answer is roughly the square root of 160, and that ball will end up falling at 12.5 meters per second. And again, even though we calculated a positive value, that answer will be negative in sign because the ball is falling down.